we are focusing on Ernest Rutherford, who came up with his own idea of the atomic model. There are many incorrect things about Rutherford's model. First, that he said electrons can move anywhere within the volumeless space around the nucleus, and his atomic model did not explain the properties of electrons, and atoms seemed to be too balanced. When an electron would absorb or release energy, they were expected to collapse. Now let's go back in time to find out more of the discoveries and improvements of the atomic model. In 1900, a German physicist named Max Planck developed the quantum theory of energy. In 1918, he was awarded with the Nobel Prize for his achievement of this theory. Planck said that energy is transmitted in small packets, known as quanta, instead of long, eternal waves. With his idea of quanta, he used it to explain hot, glowing matter. With his idea, he was able to measure the energy of a quanta. He did this with the equation of E equals hv. In the equation, E stands for energy, which is equal to hv. The h stands for his creation of Planck's constant, which is equivalent to 6.626 times 10 to the negative 34, and the v stands for velocity. In 1905, the next scientist that contributed to the atomic theory was Albert Einstein. He created the theory known as the quantum theory of light. His theory said that light does exist as particles, which are called photons. In order to know the size of atoms or molecules given in a certain space, Einstein created an equation known as E equals mc squared. The E stands for energy, which is equal to mc squared. The m is the mass times c squared, which is the speed of light squared. Another contribution from Einstein was that he was able to prove the existence of atoms and molecules by working on the theory known as the Brownian motion. Using this calculation, he was able to figure out the size of these particles and atoms. In 1913, Niels Bohr was able to come up with his own atomic model with information he gained from the Rutherford model and Max Planck's quantum mechanical theory. His model had a positively charged nucleus and was surrounded by negatively charged electrons, which traveled in fixed orbitals. An electron could only jump between orbitals by either releasing or absorbing a photon. He said that the number of electrons in the outer orbit determines the properties of an element. There can only be 2 electrons in the most inner orbit and at most 8 electrons in the second most inner orbit. In 1925, a man named Werner Heisenberg created the uncertainty principle. This theory proved Bohr's model wrong because Bohr said that you can know the exact locations and energies of the electrons in an atom. His uncertainty principle said that it is impossible to know exactly both the velocity and the position of a particle at the same time. He realized that electrons do not travel in the orbits, and he also calculated the behavior of electrons and subatomic particles that make up an atom. With this discovery, it helped make a better understanding of the patterns of electrons. Heisenberg came up with the idea that the outside of the atomic nucleus is surrounded by an electron cloud, which is the name given to the electrons that are widely spread out around the atomic nucleus. In 1926, Erwin Schrödinger also proved Bohr's model as incorrect. What Schrödinger did was that he combined the equations from the de Broglie equation with the behavior of a wavelength to explain the chance of finding the correct location of an electron at a certain time. This was known as the quantum mechanical model. In this model, the nucleus was surrounded by a cloud of electrons. In the thin parts of the cloud, there was a small chance of finding an electron. In the dense parts of the cloud, the chances of finding an electron was higher. Ever since 1932 and the continue of today, scientists have discovered and improved upon many things about the atomic model. They have discovered additional particles in the atom. Today's current atomic model contains a nucleus which holds the protons and neutrons and smaller particles called quarks, which are within the protons and neutrons, and the electrons are always in constant movement around the nucleus.